All right, so lesson number 2 is on Pythagorean Theorem, and Pythagorean Theorem is sort of a bigger deal, and it's going to be something that's pretty important. Again, moving forward in grade 10 and grade 11, it kind of comes up all the time, and it is something that you should have seen in elementary school, but again, we don't know exactly what last year looked like for everybody, so you may or may not have seen this. If you haven't seen it, you may want to watch the video a little bit more slowly, or just be aware of that. And as always, ask questions if you have them. If you've seen it before and this is familiar, that's great. There are different ways of doing this, so I'm gonna try it one way, and this way I think is gonna work for a lot of people. I'm gonna do it this way because I think it works for the most people, but if you've seen it a different way before that you're more comfortable with or something like that, it's probably okay, but you should always be getting the same answer, so just be aware of that. So let's get into it. Pythagorean theorem can be used to find side lengths of sides in right triangles. Now, what is a right triangle? Okay, and it doesn't work in other triangles, so Pythagorean theorem only works for right triangles. And a right triangle is something that has a 90-degree angle in it. So if I look at this first example, there's your 90 degrees, right? That's the symbol that we use to indicate that an angle is 90 degrees. We turn it into a little square. Sometimes we call it a square angle. And so that means 90 degrees. If I had a triangle without a 90-degree angle, then I couldn't use Pythagorean theorem. So Pythagorean theorem is just a formula that relates the lengths of the three sides in the triangle. There's a few important things to know about this formula, and then once we know it, we got to pay attention to a couple little details when we go ahead and use the formula. Otherwise, it ends up being kind of the same thing every single time. So one of the things that we need to know is that C is one of the side lengths, and C is always the biggest. Now, there's a couple of ways that I know that. I know that because that's just true of Pythagorean theorem. But the other way that I know it is if I'm adding up two other lengths and they add up to the third, well, the third has to be biggest, right? So if A and B, now it's not A plus B, it's A squared plus B squared. But if it's side A and side B are adding up to side C, then side C has to be bigger than those two, right? That's just the way that it works. So that's one thing that we want to think about and always want to be paying attention to really, really carefully, recognizing that C is the biggest, okay? And that's going to come up when we start the first example. We're going to talk a lot about that. In every example, we're going to talk a lot about that. The second thing that we want to know is, and this is sort of similar to what we were doing in the last lesson, but it's not quite the same, but how do I solve this equation? So no matter what happens, you're going to be given two of the side lengths. Take a look at the example. We're given two of the side lengths, and we have to solve for the third. So we have an unknown. So this is always going to be an equation that you're solving. In order to undo the things that are happening in the equation to find the unknown value, we have to do something about the squared. So if you are solving for C, you're going to take the square root of both sides. I know this might seem a little bit strange, but when I take the square root of C squared, I get C. And on the other side of the equation, I get the square root of A squared plus B squared. So you don't have to understand it. I'm not going to spend a lot of time right now explaining why this is the case, because I don't think that's going to help. It's something we can talk about more if you would like to, but it's kind of just something you want to remember, that this is how you do it. And very similar to the last lesson, a big part of this is just going to be figuring out how do you punch this into your calculator. How do you, you don't have to memorize the formula. You can have it written down, but you do have to know how to use it, how to punch it into your calculator, and there's a few different circumstances that change things a bit, okay? So that's what you really need to know. So if you're looking for the longest side, then you're going to do this, okay? If you're looking for one of the shorter sides, and it doesn't matter if it's A or if it's B, if I'm looking for A, what I'm going to do is I'm going to move the B to the other side. And I'm going to do that by subtracting B squared, which might seem like a strange thing to do. We have done a little bit of this before, but I don't want to worry too much about that again. But I'm going to move the B to the other side, so I'm going to get C squared minus B squared. And again, we're going to have to take the square root because it's A squared, and to undo your A squared, you use square root. Or similarly, if I'm solving for B, and again, which one's A and which one's B won't matter once we get into these actual questions. If I'm solving for B, it would be C squared minus A squared, and I would have to take the square root. And hopefully what you notice is that it's always the biggest minus the smaller, okay? That's not true in all of mathematics, but it is true in Pythagorean theorem. You're always doing C minus the other one because C is the biggest. If you're trying to find C, you're adding them. If you're trying to find one of the other lengths, you're subtracting, and you have to have C in front. Otherwise, it's the same every time. Okay? If this feels a little strange right now, that's fine. That kind of makes sense. Once we start doing some examples, it will hopefully help a lot more, and you'll see how this all works out. So let's take a look at the first one. Solve for each missing side. Now, first thing we want to do is we want to figure out which one is the longest. And some people you might be able to tell just by looking at it, but it's not always obvious. Some triangles can be a little bit deceiving. But which one do you think is the longest? So hopefully you pick 25. And if you weren't sure, or you might already know this as well, the longest side is always across from the right angle, and it has a special name. So when I find the right angle, and again, Pythagorean theorem is always right angle triangles, so I'll always have a right angle. I can go across from my right angle, and that will be my longest side. Like I said, it has a special name. It's called the hypotenuse. Again, when you get into grade 10, that's going to be a really important word because of other stuff that you do. For us right now, we just need to know that it's the longest side. So that's going to be your C. Which one's A and which one's B doesn't matter. So I could say that this is my A and this is my B. I'm looking for A, so I'm going to use this formula. So A is the square root of C squared minus B squared. You don't have to write that down every time. What we're going to do is we're going to realize that it's x equals the square root of, and because I know the longest one, I have to subtract. So I do 25 squared minus 9 squared. And this is the part where maybe, especially after you've done this a few times, it starts to make sense, where I'm always doing the biggest one minus the smaller one, right? I have to square everything, and I have to take the square root. So those are kind of the things that you need to remember about Pythagorean theorem, but if you can remember those things, it ends up being very similar every single time you do any question. So let's see what this looks like. Now I'm going to punch it into the calculator. Depending, if you have a fancy calculator like this one, take a look. You can enter the whole thing in all at once. Hit that equal button, and it's just going to spit out the answer, and that's fine to do it that way. Otherwise, you might do this in a few steps. Now, I wouldn't recommend writing this step, but you can if you want. 25 squared is 625. Minus 9 squared, which is 81. 625 minus 81. So this is a step that maybe isn't a bad one to write down. Some people are going to want to do this. So that green step is optional. Okay, you could just do that part on your calculator and then write down this one. and then take the square root of that number. And again, like in the last lesson, sometimes it gives me this funky, annoying answer. So I'm going to figure out which button gives me my decimal version. That's the one that I want. So we're going to round this. I'm just going to round it to one decimal place. And don't forget units. If you're given units in the question, you should have units in your answer. So 23.3. And again, notice that is smaller than 25. And it should be, because 25 is the longest side. It's the hypotenuse. It's across from the right angle. And that's why we had to subtract. If you had used the other version and added, you would get the wrong answer. You would get a side length that's longer, and that doesn't make any sense in this situation. Okay. So that's how you do that one. Again, I could have done it, because this calculator can do that. I could have done it all together in one shot. But that will depend on your comfort level, how you like to use your calculator, and what kind of calculator you have. Okay, let's try another one. So what's different about this one? Well, when I look at the longest side, that's the one that we're looking for. That's your x this time. So in this case, I'm going to use the other version of the formula. So this one is, I'm adding them up to get the bigger one. And again, which letters you use doesn't really matter. You don't even have to use the letters. You don't have to write the formula. You have to know whether you're adding or subtracting. So let's do this one and then go back and compare the two questions that we've done so far, and notice how they are, how they're similar, but also more importantly, how they're different. Okay. So x is what I'm looking for. It's the longest side, which means the other two have to add up to it. And I have to square everything and I have to take the square root. That's always true. I'm always squaring everything and always taking the square root, right? So I'll do this. 8 squared, is 64. 15 squared is 225. So 225 plus 64 gives me 289. So the square root of 289, again, you can write that down if you want, but you don't have to. And this one gave me an exact answer, so I don't have to round. And this one's in meters, so 17 meters is the final answer. Now let's just go back and compare these two. Notice, here's where hopefully everything will start to click if it hasn't already. In the first one, I'm given the longest side. So I have to subtract from the longest to get one of the shorter sides. But notice I square everything and then take the square root. So it's the biggest minus the smaller, square them both, and then take the square root at the end. In this case, I'm looking for the longest side. Well, the two shorter sides have to add up to the longer side. So I end up adding. I still square everything, and I still take the square root in the end. Okay? So the similarities are you're always squaring both parts, and you're always taking the square root as your last step. The difference is you might be subtracting or you might be adding. And I think if you think it through this way, it's easy to, it makes it a lot easier to remember. And you just think about it. Okay, do I subtract or do I add? Because sometimes I'm doing one, sometimes I'm doing the other. And then otherwise, you always have to remember to square everything and then take the square root. Okay, determine if each set of numbers below belong to a right triangle. Now, again, this is kind of an interesting question because it makes us think about some of the relationships, but it's also a question that we've seen on EQAO. So that's one of the reasons why we're doing this, but it will also just kind of help us think about the relationships. If it's a right triangle, okay, then Pythagorean theorem will work. When I look at these three numbers, how do I know where to put them? Well, 5 is the smallest, and that looks like 5. I know that across from the right angle has to be the biggest, so that's got to be 13. And then the last one has to be 12. And if it's a right triangle, that means 5 squared plus 12 squared, the two smaller ones, will have to add up to the third one. So what we're doing is we're asking if that's true. Okay? And again, I'm just going to check it on my calculator. 13 squared is 169. 5 squared plus 12 squared is also 169. So, yes, these ones do belong to a right triangle. Okay? And that's just how you would do it. You have to think about which one's the biggest, which goes by itself, and just check to see if it works. Again, this is not something that's going to come up a lot in tests or anything in this course, but it's just something interesting that we can think about. And if there were EQAO, then it's something that would come up on EQAO. So again, 1, 2, 3. Well, there's your, that looks like the shortest. That one is the longest because it's across from the right angle, which means 2 has to be there. So what I'm looking for is 1 squared plus 2 squared. The two smaller ones, does that add up to 3 squared? Well, I know 3 squared is 9. That's one that we've talked about before. If I don't know that, I do it on my calculator, but I already know that one. 1 squared plus 2 squared. So 1 squared is 1. 2 squared is 4. 1 plus 4 is 5. Or 1 squared plus 2 squared, just do it on my calculator. 5. Therefore, this one is not in a right triangle. Okay. So again, if that's a little bit confusing, don't stress over it. Don't overthink it. We're going to worry more about the questions where you're given a triangle and you have to solve. But this one does make us think about it a little bit, and it does help just remind us about the relationship with the longest side, where it goes, and how the other two have to add up to it. Okay, and it helps with this fundamental idea that this is Pythagorean theorem is only true for right triangles. So you could draw a triangle like that, but it wouldn't have a right angle in it. Okay, so here's what I'm going to suggest. I'm going to say there's 2 more examples, and then we're going to be done. I think you should pause the video and see if you can try these on your own, and then we'll walk through them together. And, you know, now that you've seen it once, both of these are very similar to the other questions that we did, the first 2 questions that we did. So you can go back and look at those in your notes to get an idea of how to do it. And then we'll go over it together. If you think you can have a shot at it, if you think you're comfortable and you want to try on your own, great, pause now and do that. If not, I'm going to give you a little tip next. Then you might be able to pause and try it. So here's the tip. When I look at these 2 questions, what is different about them? They're both right triangles. This one gives us the longest side. This one's looking for the longest side. So that's your tip. If you look back at the first example, you'll do each of these exactly like the one that it's similar to. Okay, and that's the first thing that you need to be thinking of. Am I looking for the longest side, or am I looking for one of the shorter sides? Because I've given the longest side. I already know the measurement of the longest side. And that's going to tell you whether you're adding or subtracting. Otherwise, the questions are going to be the same. So with that little reminder and that tip, now you can pause and see if you can try this on your own, and then we'll take it up. Okay, so what we want to remember for this one is when I'm finding x, it's the biggest minus the smaller, because this one's bigger than both the other 2, so I have to subtract to find the one I'm looking for. But I have to square everything, and I have to take the square root of everything. Okay? And so I'm going to do 19 squared, which is 361, and 13 squared, which is 169. Okay, and then I'm going to do 361 minus 169, which is 192, so square root of 192. And then I'm going to take the square root of that, get the decimal answer, and round to one decimal place, 13.9 centimeters. So again, I subtracted because I'm looking for one of the smaller sides. For this one, I'm looking for the biggest. So the other two have to add up, to it. But I always have to square them both, and I always have to take the square root of everything. How about this time I show that extra step? So 100 squared is 10,000. 110 squared is 12,100. And then I take the square root of everything, add those together. Okay, and I get the square root of 22,100. Which works out to 148.7. And again, this one happens to be in centimeters as well. Okay, so hopefully that helps, that you've now seen a few examples. What you really, again, want to notice is if you're looking for a smaller side, you have to think about which one is the longest side across. Notice how I always am writing these arrows. I think that's a really good thing to do. Okay, so figure out what the longest side is. If you're looking for a smaller side, you're subtracting. If you're looking for the longest side, you're adding. Otherwise, you can see how you're always squaring everything and always taking the square root. Okay, and so again, you should notice that the practice has questions that are very similar to these. Every time it's going to be kind of the same thing. So use these examples as a model of how you can do all the other questions. Okay, and good luck.